That way you guys can have plenty of time to work on homework, which is going to be due on Wednesday this week. So, okay. Let's kind of walk through each problem. First set of problems you're going to have. So I'm going to try to walk through this as fast as I can. What they're going to do, they're going to give you coordinates. 2, 6, 7, -1, 0, -5, 4, 8. Okay, the first set of problems, all they're going to ask you to do is graph. So I will give you graph paper today. Do you guys feel comfortable with graphing coordinates on an actual coordinate plane? Mm-hmm. Okay, good. Okay, that'll be pretty easy. I'll supply you with those graphs. That you'll just staple to the normal book assignment, because the book assignment you're going to have will just require normal notebook paper, so they'll staple it to the back. Just make sure you number the problem. It's like the first 4 or 5. I think I just wrote like 2 through 6 or something like that. These are the individual problems. Just put them all in one graph. You don't need to connect them with lines or dots or anything like that, because these are just, it's going to be a scatter plot. The dots will be all over the place. Just kind of review how you're going to plot points and stuff. Good to go? Second part you're going to have, they're going to give you the table. So this is the next part. So I'm going to provide you a table. It'll have a series of different functions on it, like y1, y2, and then they're going to ask you a series of questions about that table. So let me give you a couple numbers here. Let's go -2, -1, 0, 1, 2, 3, and let's say this is -4, -2, 0, 2, 4, 6. And this one is 4, 1, 0, 1, 4, 9er. Okay. So the first type of question they're going to ask is, which is the function that represents y1? That'll be like the first question. That's something I warned you of like last Wednesday or Thursday, where down below, maybe this is question number 15, they're going to have 4 different functions sitting there. And they want to know which function represents this graph. So maybe the functions are like f of x equals 2x, f of x equals x squared, f of x equals x plus 4, and f of x equals x minus 8. Something like that. And you have to figure out which one represents it. So what I mean by y1, so let me separate these a little more. Okay. To figure out which one of these 4, you just take these numbers, take these x's, plugging into the formula, whichever one you think it is, and see will it give you the y1 function answers. So, anyone know which one it is? First one, when you multiply by 2. So when you multiply by 2x, or you take your x numbers times 2, -2 times 2 is -4, -1 times 2 is -2, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. So yeah, it's this one. So this would be your answer for that first problem. Which function represents y1? It's this one, because that's the one that gives you those y values. Make sense? The second question, what would represent y2? It would be the same situation. They would ask you a series of parts about it. It's the x squared term. That's just how I made it. So that's your first questions out of that table. Then the next couple of questions, what they ask is, do the graphs intersect?
Morning. Sorry, Mr. Wood. The dance bunny, do you have it or was it?
Mr. Haig took it.
Mr. Haig took it.
He did.
Was it in a bigger one or a small?
It was just in a blue, I don't know, what is that? 5 by 8?
Yeah, okay, thank you.
Okay. All right. So the secondary question that we'll ask, does y1 function, does it intersect the x-axis somewhere? Does it hit the origin? Those are the types of questions. Well, both of them do hit the origin, by the way. They hit 0, 0 and 0, 0. It could be, do the 2 graphs intersect? Yes, they do. They have the same coordinate, 0, 0. It could be a question like, does it have a y-intercept? Well, it has a y-intercept right at, the origin, 0, 0. Again, is there any other points where they intersect? 2, 4? That'd be another spot where they both cross each other. Because they share the coordinate 2, 4. That's another spot where they intersect. So it'll be a series of questions, and that's I think the 29 through 40, where it's just on one table. That's all they give you. They don't give you a graph for it. They just give you a table, and they ask you just a ton of questions about it. And they're trying to get you to interpret the idea behind it. Okay, questions at all about that second part of your homework? Okay, all right, perfect. Let's jump to the next part of the homework, which is on a different page completely. These are on like one page, the next page completely. The third type of questions that they're going to have you do is where they're going to have you, they're going to give you a set. So something like this again, 5 comma 2, 8 comma 3, 9 comma 4, and 10 comma 4. Okay. Something like that. And the question is, what they ask you to do is take that data and write it down in the different forms of your relations. So like one of the questions is it a function to begin with? That's one of the questions we need to review, because that was something we introed on Friday. Can you write it down in a mapping? Can you write it down in a table? Can you put a graph to it? That's why you need graph paper. Can you do all those little things to this one problem? So I think I only gave you 2 of these, and I think they do the same thing. They give you about 5 or 6 coordinates per problem. So let's say this is number 4 in your book. The first part, is this a function? So what I mean by that is how you can tell if this is a function or not for every element in the domain. So every x number. Is there, geez, what am I doing here? Is there one answer coming out for it? So what I mean by that, if you look at each of those numbers, 1, 5, 8, 9, and 10, do they have one answer behind it? Yes. So this is a function. What would make it not a function is if it had, so it had all those, but it had an extra coordinate in the set, so at the very end it had something like this. Now this isn't a function, because the reason why it failed is that the number 8 was already used. And suddenly it has a different answer behind it, not a function anymore. It's not a function because it's like when you type the number 8 in a calculator, it shouldn't just magically spit out a different number each time you type it in. It should give you the same answer consistently. So this is not a function because of this, right here, those two. If you look at the back, I don't care that the answer 4 repeated. What I care about is that for every x, there's only one answer that's behind it. And I don't care what the answer is behind it, but there's only one. Since it repeated the number 8 twice, it's kind of a red flag. All right, questions at all about how to know if it's a function or not? This is a function now that I've erased that one coordinate. And then what you have to do is write these in, your different forms. So if I'm going to write it as in a graph, you just put the dots on one graph. Don't connect them with lines or anything like that. Second, we'll do a mapping. This is one of the parts we introduced on Friday. Mapping, you put the numbers in least to greatest order. 9 and 10. There we go. So there's your x's. The y numbers are going to be over here. So the y numbers, putting them in least greatest 2, 3, and 4. So there's only a couple numbers that are in there, because they repeated the same numbers more than once. So the number 1 went to 4, 5 went to 2, 8 went to 3, 9 went to 4, and 10 went to 4. That's a mapping. Can you handle drawing a mapping? Okay. Graphing we already talked about. Table set, same thing. On a table, you put the numbers on the x, or on the x side, you put the numbers in least to greatest order. 1, 5, 8, 9, 10. And then you put all the numbers that are across, directly against direct numbers across. So 5, 2, 3, 4, and 4. Like that. I don't care that they went in alphabetical or numerical order on the other side. I care about the x side, the domain side. So, looking at a mapping, looking at a table, you can see if it's a function or not, again, because every x should only have one answer, one arrow coming from it. Inverses, you have to reverse the order of the coordinates. That's all you have to do. So, I give you 2 of these. It's going to be slightly different instructions than the book has. It's the second page, I'll kind of warn you which ones I want you to do the extra work. So on these, like number 4, there's 2 of them, number 4 and number 5. I'm going to ask you to tell me if it's a function or not, and then give me all the different forms of relations for those problems. So you have to give me all 5 forms that we have, and they're right up here if you don't know. And they don't have to be in any specific order. Okay. The only one you have to put on the graph is obviously the first problem, and then these 2, I think. Everything else is just a simple question. Okay, questions on those. That's your 3rd homework type of problem. Perfect. 4th type of problem today. The 4th homework problem. The 4th homework problem. They're going to have you look at a graph and interpret things about it. So I'm just going to draw a rough graph here. Let's go up here. Okay, so here we go. Something like that. Okay, so these are going by ones, by the way. They're all by ones, so I didn't try to go up to too far. And let's say this represents f of x. So f of x is the name of the function. The function represents that curve somehow. It's some formula in the back when we don't know what the formula is. But then the questions are, and I think I gave you quite a few of these. These are what you're going to spend the most time on today, is interpreting what's happening on the graph at certain values. So for instance, what would happen at f of 2? So what that means is you have to find 2 on the x-axis and then tell me what is the y answer that's coming out of that thing. So here's the number 2. What's the answer right there? -1, that's your answer. That's all you have to put. That's seriously how easy it is. But I gave you a bunch of them. So like one of the questions might be, what's going to happen at 4 down the road? Well, it's going positive. So it's so what I would say, like if you don't know, you can kind of interpret what's happening here. Maybe you can kind of see where the arrow is going. But if you don't know, maybe they said, you know, what's going to happen at 40 down the road? Well, 40 down the road is like way over here. 40 is way down there. And this thing's skyrocketing off to infinity. So I would just say it's going towards positive infinity. You know, that sort of thing. I can't even, guess what the number is, but that's the direction it's going towards. You know, that type of thing. You're interpreting where the graph's going. Maybe there's a hole in the graph. So maybe there's this like little dot here. Or there's an open circle there. Well, then there's no solution. So it does not exist. Because maybe at f of 2, it has a does not exist there. Like not 0, it doesn't exist. There's an open circle there. There's no answer. So just be careful that they're going to give you a graph, they're going to have you interpret some stuff from it. So it's kind of like a table idea, but now they're asking you a series of questions about it. Okay, that's your fourth and final type of homework problem. It's basically graphing, interpreting graphs. Because then tomorrow we're starting to really kind of more challenging stuff. Questions at all? Perfect. All right, here's your homework today. I'm going to leave that list of the relations because that's what I want you to do on this one problem. I'll kind of warn you which ones those are. I'm going to put it on the board and we can get started. It's due on Wednesday. Wednesday. So, all right, first page, because it's over 2 different pages here, because I kind of split it up so I could get the problems I wanted. First problems are 2 through 12. And I said they're kind of big, there's a lot of problems there. The 2 through 12, you're just graphing all of those dots on one graph. I will give you graph paper here in a second. So again, you're going to graph these in one graph. So you're going to graph and put them all on one graph. Just their individual dots. So problem number 2 is a dot, problem number 3 is a dot, so those are pretty easy. Okay, next. We're doing 14, 18, 20, 28, 29 through 40. So now, these first couple here, these are viewing windows. It's going to have you check like which grid represents which viewing windows. So you got to kind of look those back up again. That was the one problem I didn't review with you today, because I want to see if you guys can handle that. 29 through 40 is the one where they give you a table. They ask you like 90 questions about the table. And now the second page, page 159, 4 and 5, these problems are the ones where you have to do all the relations. So this is slightly different instructions than what the book says. The book just says, is it a function or not? I want to know, is it a function or not, and what are all the different forms of relations for them? Graph, table, mapping, you got to do each one. 65 through 77, same thing. They're going to have you interpret a bunch of stuff from a graph, like it's all this stuff. Like find f of 2, find f of 10, find f of -4. And then the last one, 81, is, I think it's the same as 77. they give you a graph, like a picture, and they're gonna ask you like, what's the domain? Oh, it's from negative infinity up to positive infinity. What's the range? It's going from 4 and up. That type of thing. Is it a, is it a continuous graph? Is it flow? All right, well, there you go. And we will try to review a couple of those problems tomorrow in case you're kind of lost. I'm expecting there's gonna be probably questions on maybe that last one, like 81. So there you go. I'm gonna give you some graph paper, and then you're off to the races. You can move around in the room, you can sit wherever you like, and work. Hope everyone had a nice relaxing weekend. You will not need all these graphs, but you're still gonna staple it to it, so. If somebody lost their pre-calc book, there's one in the back, I don't know, it's been sitting in the back of the room for a while. I don't know whose it is.